PUC2 ಸೈನ್ಸ್ ವಿದ್ಯಾರ್ಥಿಗಳು ನಮಸ್ಕಾರ ಸ್ಥಿತಿಗೆ ಬನ್ನಿ. ಇಷ್ಟ ದೇವತೆಗೆ ಗುರು ಹಿರಿಯರಿಗೆ ಪ್ರಾರ್ಥನೆ ಸಲ್ಲಿಸಿ ಇದನ್ನೆಲ್ಲ ಅಭ್ಯಾಸಗಳನ್ನು ಏಕಾಗ್ರಚಿತ್ತದಿಂದ ಶಾಂತ ಮನಸ್ಸಿನಿಂದ ಮಾಡಿ ಮುಗಿಸುವ ಶಕ್ತಿಯನ್ನು ಕೊಡಲು, ಕಲಿತ ವಿಷಯಗಳನ್ನು ಜ್ಞಾಪಕದಲ್ಲಿಟ್ಟುಕೊಳ್ಳುವ ಶಕ್ತಿಯನ್ನು ಕೊಡಲು, ಜ್ಞಾಪಕದಲ್ಲಿರುವ ವಿಷಯಗಳನ್ನು ಪರೀಕ್ಷೆಯಲ್ಲಿ ಸರಿಯಾಗಿ ಬರೆಯುವ ಬುದ್ಧಿಶಕ್ತಿಯನ್ನು ಕೊಡಲು ಇಷ್ಟ ದೇವತೆಗೆ ಗುರು ಹಿರಿಯರಿಗೆ ಪ್ರಾರ್ಥನೆ ಸಲ್ಲಿಸಿ. Take a deep breath. Yes, good morning, my dear students. In the previous class, in the chapter 2, inverse trigonometric function, class PUC2 class students can continue. Chapter 2, inverse trigonometric functions. Inverse trigonometric functions. So I think you understood in the previous class what is the principal value and how to solve the problems on principal values. We will see. I think we studied first set in it. Let us continue with the second set of properties of inverse trigonometric function. That is, sine of, the set is like this, sine of sine inverse x, sine of set 2, sine inverse x is equal to x provided the condition is x lies between -1 and +1. Second one, cos inverse x is equal to x provided x lies between -1 to +1. Third one is tan inverse x will be x when x belongs to any real number from -infinity to +infinity. Fourth identity is cosec inverse x is equal to x when x is either less than or equal to -1 or x is greater than or equal to 1, because where sine inverse exists, excluding that cosec inverse exists. Similarly, sec inverse x is equal to x provided x is less than or equal to -1 or x is greater than or equal to +1. And the sixth in this set is cot inverse x. Again, x belongs to a real number, any real number on the number line from -1 to +1. Right? I will show you the proof of. Good morning, Dipti. How are you now? Are you okay? Fine. Okay. Fine. Let us start the proof of them. I will show one of them. You can try remaining similarly. See, sine Sine inverse x. Let us assume that how to prove this. Suppose that the question appears for 1 mark. Sine of sine inverse x. Let us assume that it is equal to y. Okay, let us assume that it is y, where x again lies between minus 1 to plus 1. When x lies between minus 1 to plus 1, if sine theta is equal to y, how do you write theta is equal to? So theta is equal to sine inverse y by definition when the restrictions are hold good. Now, how can I write sine inverse x as now? Sine inverse x is in the place of theta. Now I can write it as sine inverse x is equal to, you can write it as sine inverse y. Inverse exists when the value of x lies between minus 1 and plus 1. That implies, call it as equation 1. That implies x is equal to what? Y. Call it as equation number 2. Now we assume that y from 1 and 2, what you can write? From 1 and 2. From 1 and 2, you can write that x, wherever there is y, you can put x there. Therefore, sine of sine inverse x is equal to, wherever there is y, you can put x. I hope you understood, my dear students. You can prove very easily. Means, first of all, you assume that this is y. We don't know what it is. But we know the definition of, if this restriction holds good and theta lies between minus pi by 2 is less than or equal to theta, theta is less than or equal to pi by 2, if these two conditions are satisfied. See, when x lies between minus 1 and plus 1, theta should lie between what? Minus pi by 2 and plus pi by 2. Then both the conditions satisfy. Suppose this is theta. Theta. You used to write it as theta is equal to sine inverse of y. Then sine inverse can be eliminated. You get what? X is equal to y only. Now, from 1 and 2, you can observe that wherever there is y, I can put what? X. Hence, proved. May appear for 1 mark. Hence the proof. Similarly, you can go on proving all the 6. Cos of cos inverse x is equal to x. Right? Now you can write it as a cos inverse. You can assume it as y. I will show you another one. I will show you another one. That is cos inverse of, let second one you can take. Let cos of cos inverse x, cos of cos inverse x is equal to some value y. When x lies between minus 1 and plus 1, and it will be minus 0 to, theta lies between 0 to 1. Cos x, 0 to pi, 0 to pi. Cos 0 is 1, cos pi is equal to minus 1. When this condition satisfies, inverse of this function exists. Suppose this is, assume that this is theta. Cos theta is equal to y means if these conditions are satisfied, by definition of inverse function, you can write it as theta is equal to cos inverse y. In place of theta, you have by definition of cos inverse function, by definition of cos inverse function, you can write it as, call it as equation number 1. You can write it as cos inverse x is equal to, you can take this one as cos inverse y. Call it as, that implies when cos inverse x is equal to cos inverse y, x must be equal to what? Y. Call it as equation number 1. From 1 and 2, from 1 and 2, you can say that cos inverse x, cos inverse x is equal to, in place of y, you can write x. I hope you understood, my dear students. Observe the restrictions. Similarly, you can prove tan inverse, cosec inverse, sec inverse, sec of sec inverse x is equal to x, provided x is less than or equal to 1, x is greater than or equal to 1. See, observe here, cosec and sec will not lie where cos and sin will lie. Observe, that is, cos and sin will lie between -1 and +1. When you take the reciprocal, it will be above this. Means from x is less than or equal to -1, then x is greater than or equal to +1. There cosec inverse exists. Similarly, sec inverse exists where cos inverse does not exist. Cos inverse exists between -1 and +1. X lies between -1 and +1. Then sec inverse exists, x is less than or equal to -1 or x is greater than or equal to -1. Similarly, you can prove simple proofs of all of them. I will leave you as assignment, and remember this identity, right? You can solve the problems whenever you are given with the problems on it. Clear? That is set to. Suppose that I give one example here. Try to understand how the value will be. That is sine of. What is the value of sine of? Find the evaluator. Sine of. Evaluate. Sine of. Sine inverse 0.5. If I give you. Evaluate it. What is 0.5 is? Observe sine inverse 0.5 can be written as what? 1/2. Does the sine inverse 1/2 exist? Exists. Then sine inverse 1/2. Observe whether x lies between, this x lies between -1 and +1. You can write directly as 1/2. Okay. Try another example. Example 2, cos inverse 3/2 if I give you. Can I write 3/2? Think of it. What is 3/2 is? That is cos inverse 1.5. 3/2 means what? 1.5. What is the restriction for x? For cos inverse, x should lie between what? X should lie between what? -1 is less than or equal to x. X is less than or equal to 1. Now the value of x becomes what? 1.5 means greater than 1. Therefore, you have to say that does not exist. Does not exist. Why? Why? Cos inverse can be defined only if the value of x lies between what? -1 and +1. Now it is 1.5. Therefore, your answer should be the value does not exist. Then if I take tan inverse 2026. Tan inverse 2026. What is the answer? Can you tell me the answer of it? Observe. Tan inverse x will be x for any real number x. Observe. Is 2026 a real number? Lies between -infinity to +infinity? Yes. Therefore, you can write it as 2026 directly. Getting the idea? And suppose that I give you sine inverse 2. What is the answer? Sine inverse 2. What is the answer? See, 2 is here. What is the restriction? You have to carefully observe. Sine inverse exists only if the value of x lies between -1 and +1. 2 is beyond it. Therefore, value does not exist. You have to give the answer does not exist. I hope you are understanding the meaning of this property, and you must not leave the restrictions, right? Suppose that I give you, right? Many students blindly solve the problems. Cosec inverse 1 by 2. What is the answer? Tell me. What is the answer? Cosec inverse 1 by 2. Now observe the restriction. Cosec inverse of x is x, provided x is less than or equal to minus 1 or x is greater than or equal to plus 1. Observe. Where this 1 by 2 comes? See, 1 by 2 comes minus 1 plus 1. This will go up to infinity. This will go up to minus infinity. Where this 1 by 2 comes? 1 by 2 comes, this is 0. 1 by 2 comes here on the number line, 0.5. Means can cosec inverse exist between minus 1 and plus 1? What is the condition for cosec inverse? X should be less than or equal to minus 1. Means it should go on the left side of minus 1. And x should be greater than or equal to 1. Means it should go beyond 1. Now the value is 1 by 2. Your answer should be does not exist. I hope you understood the application of this particular property. You have to carefully observe the restrictions. Okay, got it? If I write, for example, sec inverse 7 by 2. If I give you, observe where the sec can lie. Sec of sec inverse x is equal to x, provided x lies between what? X is minus 1, number line 1, 0. What is 7 by 2 is? 7 by 2 is 3.5. Where the 3.5 comes? 2, 3, 4. 3.5 comes here. 3.5 comes between 3 and 4. Now check, is x greater than or equal to 1? Yes, x should be greater than or equal to 1. Now you can write the answer as sec of sec inverse 7 by 2 is 7 by 2. Yes, valid. I hope you are getting me. Means these restrictions you must not forget whenever you are defining, solving problems on inverse trigonometric function. I hope you understood. Such questions will appear in MCQ for 1 mark or 2 mark. Number of times they deceived you. Like this, cosec inverse 1 by 2, if you give, your answer should be does not exist. Clear? I remember this particular set too, and also I have shown you how to prove them. Okay, fine. We'll move on to the next set of properties. These set of properties you have to learn. Even the proof may be asked. Set 3. First one, sin inverse x plus cos inverse x is equal to pi by 2, provided x lies between minus 1 and plus 1. Second identity, tan inverse x plus cot inverse x is equal to pi by 2, provided x belongs to any real number. In the sense, minus infinity is less than x is less than infinity. Instead of writing this, you can simply write it as x belongs to R. Third one is sec inverse x plus what? Cosec inverse x. They are co-ratios, is equal to pi by 2, provided x is less than or equal to minus 1 or x is greater than or equal to 1. Very important property. Number of times we are using it. Okay. You try to solve this problem. The proof of them. I will show you proof. You may be asked this proof for 1 mark or 2 marks question. I will show you one by one. Okay. Let us start now. Proof of the first one. Sin inverse x plus cos inverse x is equal to pi by 2 is asked. Now how can you prove it? Let Sin inverse x is equal to theta. By definition, where x lies between what? -1 to +1 means, by definition of inverse sine function, by definition of sine inverse function, you can write it as x is equal to what? Sine theta. Can I write it? Sine theta. Right? X is equal to sine theta. Now, can I write this sine theta by using allied angle in terms of cos? We told you in the allied angle, right? Sine theta can be written is in cos by taking odd multiple of pi by 2. Can I write sine theta is pi by 2 minus theta? Can I write pi by 2 minus theta? Okay, okay, thank you, thank you. Is it clear? Okay. See, x is equal to cos pi by 2 minus theta, because in the first quadrant, second quadrant, ASTC rule you apply, studied in the allied angle. Can I write sin theta as cos 90 minus theta? Cos 90 minus theta is sin theta. Okay, based on this, therefore I told you, you must learn allied angle before you start learning compound angles, multiple angles, submultiple angles. All of them will be useful to you. You have to use them. See, when by definition, can I write this one as cos pi by 2 minus theta can be written as when x lies between -1 and +1. This condition is satisfied by definition of cos inverse. By definition of cos inverse function, can I write it as pi by 2 minus theta is equal to pi by 2 minus theta is equal to cos inverse x. Observe. Right? Let me take this minus theta to the right. What I get? Pi by 2 is equal to cos inverse x plus theta. Call it as equation number 2. Let me call this one as equation number 1. Observe. What is our assumption of theta? In the beginning, we assumed that sin inverse x is equal to theta. Right? Here you got the theta. Now you can write from 1 and 2. From 1 and 2. You can write pi by 2 is equal to cos inverse x plus, what is theta is? Sin inverse x. Thus, we proved that implies sin inverse x plus cos inverse x is equal to what? Pi by 2. I hope you understood. Any doubts in this? This is how you can prove. Suppose the question in the theory will appear for 2 marks. First step is assume that sin inverse x is equal to theta. Then by definition, because restriction holds good, whenever restriction holds good, you can write x is equal to sin theta. Otherwise, you cannot, because the inverse trigonometric function exists if and only if it is 1, 1 and on 2. It is 1 on 1 and on 2 when x is -1 to +1 and angle theta is minus pi by 2 to plus pi by 2. Clearer? Now I can write it as x is equal to sin theta. Now you can write a sin as cos pi by 2 minus theta. But as the restriction holds good, pi by 2 minus theta can be written as cos inverse x. Take a minus theta to the right, you will get a cos inverse x plus theta, but you assume that theta is equal to sin inverse x. I hope you understood, right? I will show you another one also. Third one you can try on your own. Let us prove the second one. Second one. Try to prove this. Try to prove this. Okay. We'll take the second one. Tan inverse x is equal to, let us say, theta. Where x lies between what? X belongs to real number. then theta will lie between what? For tan x, minus pi by 2 is less than theta. Theta is less than pi by 2. Therefore, its x will be minus infinity is less than x, x is less than infinity. The same thing you can simply write it as x belongs to R. Because tan pi by 2 is infinity, tan minus pi by 2 is minus infinity. So, by definition, call it as equation number 1. By definition, you can write it as x is equal to what? Tan theta. Because restrictions hold good. Can you write tan theta in terms of cot? Because we have to prove cot theta. That implies x is equal to cot pi by 2 minus theta. Can I write it? Cot pi by 2 minus theta, co-ratio, right? Co-ratio of tan is cot is tan. Therefore, you can write it as in the first quadrant, cot positive, cot pi by 2 minus theta, right? Now as a cot condition is also satisfied here. Same condition holds good for cot also, right? Pi by 2 minus theta comes in the first quadrant. What is the restriction for cot here? Cot can lie between what? 0 to pi. 0 is less than theta. Theta is less than pi. Because minus infinity, cot 0 is plus infinity is less than x. X is less than positive infinity. Do you think pi by 2 minus theta comes in the first quadrant, means it lies between 0 to pi? Now, by definition of cot inverse, you can write it as pi by 2 minus theta. Pi by 2 minus theta. If you have got any doubts, you can ask me to repeat in the chat box. You will get a cot inverse x. Any doubts in this? Yes. Can you hear me? What lesson? Ask the doubts. Any doubts in this? Okay. I hope you got it. See, tan inverse x is equal to theta. They have given x belongs to R, means theta will lie between minus pi by 2 to plus pi by 2. Then now definition is applicable. Otherwise, these restrictions are not there. Definition cannot be applied. You get x is equal to tan theta. Now, I can write a tan theta in the first quadrant as cot pi by 2 minus theta. What is the restriction for cot theta? To define inverse of it. Theta should lie between 0 to pi. Because cot 0 is infinity, cot pi is minus infinity. When these conditions for cot inverse exist, you can write by definition of cot inverse, pi by 2 minus theta is equal to cot inverse x. Take a minus theta to the right. You will get cot inverse x plus theta. Cot inverse x is equal to theta. Call it as equation number 2. Now, from equation 1, what is theta is tan inverse x. You can easily prove this as pi by 2 is equal to cot inverse x plus tan inverse x. You can write it as tan inverse x plus cot inverse x is equal to pi by 2. Remember how to prove the second identity, and understanding these identities, their restrictions, you can solve the problems comfortably. Without restriction, inverse trigonometric function does not exist. For every step you show, while proving it, they will expect how you took cot inverse, you have to explain here. Because pi by 2 minus theta lies within the range, within the restriction, then you can prove it. Similarly, you can try sec inverse x and cosec inverse x is equal to pi by 2 on your own. Let me move on to the next set. Very important sets. One by one, you go on making perfect, right? We are using multiple angles, you are using submultiple angles, all of them you studied in the first PU are applicable here. Take next one. Sin inverse minus x is equal to minus sin inverse x, provided x lies between minus 1 and plus 1. Provided x lies between minus 1 and plus 1. Take next one. Cos inverse minus x is equal to cos inverse minus x is equal to pi minus cos inverse x when x lies between minus 1 and plus 1. Let us study it. Tan inverse minus x is equal to minus tan inverse x, provided x belongs to a real number. Fourth one. Cosec inverse of minus x is equal to cosec inverse of minus x is equal to minus cosec inverse x, where x lies between what? Minus 1 to plus 1. Because cosec inverse can be defined in the first and fourth quadrant. Then sec inverse of minus x is equal to, again you can take pi minus sec inverse x. Then cot inverse of minus x is equal to, check, where x lies between what? For sec inverse, x is less than or equal to minus 1 or x is greater than or equal to 1. Even for cosec also, sorry, x is less than or equal to minus 1 or x is greater than or equal to 1, because that is the restriction. Cot inverse minus x is equal to pi minus cot inverse x, provided x belongs to the real number. Okay, let us try to prove one by one. Proof of it. How to prove this one? First one is sin inverse of minus x is equal to minus sin inverse x. How do you prove this? You can assume that first of all you prepare all the sets. I think this is set number 3 or 4. Third one, let sin inverse minus x is equal to theta. Assume it. What are the restrictions? X lies between minus 1 and plus 1 means theta will lie between what? Minus pi by 2 is less than or equal to plus pi by 2 less than or equal to pi by 2. Restrictions are very, very important. When x lies between minus 1 and plus 1 and theta lies between minus pi by 2 to plus pi by 2. You can write it as, that implies by definition of sin inverse, you can write it as minus x is equal to sin theta. Can I write it? Minus x is equal to sin theta if these restrictions are satisfied. Multiply both sides by minus 1. Multiply by minus 1. Minus into minus becomes plus x. Here you can write it as minus sine theta. Now you can use allied angle, right? Can I write what is sine minus theta? Fourth quadrant. Trigonometric ratios of minus theta. ASTC. What is sine minus theta? Minus sine theta. Cos minus theta. Cos theta. Only cos and sec are positive in the fourth quadrant. Therefore, minus sine theta can be written as sine minus theta. Right? When theta is satisfying the condition, by definition of sine inverse, you can write it as minus theta is equal to sine inverse x. Minus theta is equal to sine inverse x. Right? What is your assumption of theta? Observe. Okay. What is theta? Take this minus, multiply this by minus sign, you will get theta becomes equal to what? Minus sine inverse x. Call it as equation number 2. Observe 1 and 2. What do you observe? Here theta is sine inverse minus x is equal to theta. Now we got theta as minus sine inverse x. Now you can say that from 1 and 2, what you can write is sine inverse minus x is equal to, what is theta? Minus sine inverse x. Remember, hence the proof of it. Hence proof. Study carefully. If you have got doubts, you can ask me in the doubt box. Is it clear? Is it clear? Observe. Sine inverse of minus x is equal to theta. They have given that condition is minus 1 to plus 1. When minus 1 to plus 1, theta will be minus pi by 2 plus pi by 2. Now definition can be applied. Sine inverse minus x is equal to theta means minus x is equal to sine theta. Multiply by minus 1, you can write it as x is equal to minus sine theta. Minus sine theta can be written as sine minus theta. Okay. Now definition can be applied. You will get minus theta is equal to what? Sine inverse x. Multiply both sides by minus, you will get minus sine inverse x. From 1 and 2, you can observe what is theta? Theta is equal to sine inverse x minus x. And sine inverse minus x is equal to theta. Theta you got it as minus sine inverse x. Hence the proof of the first one. Okay. I will just prove another one today. As today is Saturday, I have to go to the school by 8 o'clock. I will solve second one. You try remaining set. After this period, we will meet directly on Monday at same time. Morning. I will prove second one. Very interesting. Similarly, you can try remaining 4. I will show this set today. Right? These sets you make a list. Remember, let us start the proof of it. Let cos inverse minus x is equal to theta. What is the restriction given to you? Minus 1 is less than or equal to theta. Theta is x is less than or equal to 1. The values are 0 is less than or equal to theta. Theta is less than or equal to pi, because cos inverse exists. Cos inverse exists in first and fourth quadrant. Second quadrant. Now, as conditions are satisfied, by definition of cos inverse, you can write it as minus x is equal to what? Cos theta. Interesting. That implies you can take multiply by minus 1 and you will get x is equal to minus cos theta. Now you have to take a cos theta in the first and second quadrant. In the second quadrant, according to ASTC rule, except sine and cosec, rest are negative. Observe, can I write this minus cos theta as cos pi minus theta, 180 minus theta? Cos 180 minus theta is minus cos theta. I am writing minus cos theta using allied angle. Therefore, I told you allied angle is very, very important while proving the inverse trigonometric functions. So that implies by definition, again by of cos inverse, you can write it as pi minus theta is equal to what? Cos inverse x. Do you agree with me? Pi minus theta is equal to cos inverse x. Right? You can take cos inverse x to the left and minus theta to the right. What do you get? Pi minus cos inverse x is equal to what? Theta. You call it as equation number 1. You call it as equation number 2. Observe. From 1 and 2. What is theta is? Theta is from 1 and 2. From 1 and 2. 1 and 2. What is theta is? You will get pi minus cos inverse x is equal to theta is cos inverse minus x. See the look at the changes. Therefore, you can write it as cos inverse minus x is equal to pi minus cos inverse x. I hope you understood, my dear students. Okay. Right. After this class, directly we'll meet on Monday. Okay. So Monday next week we'll be continuing with in chemistry the chapter we started and continue with inverse trigonometric function on alternative days. Remember, and if you like the Lokg channel technically powered by Vidyam sir, you can invite more friends and join, subscribe, right? So shortly after the chapter, I will take both multiple choice question test and different level questions I will solve on ITF. Okay, inverse trigonometric functions. We have to cover this month, July month, 3 chapters. One is inverse trigonometric function, relations and functions, first chapter, then matrices. Okay. Continue in the next period on Monday. Bye bye. See you.